Okay, today we're going to talk about a friction problem and how to find the force of friction, coefficient of friction, and do some other things with it as well. So let's just start off by reading the problem. It says a force of 200 newtons is required to pull a 60 kilogram crate along the ground at constant velocity. Okay, this is a key term here. Constant velocity, I'm going to underline that one. The questions that we're supposed to find, it says number one, what is the force of friction? Number two, what's the coefficient of friction? And number three, what force must you apply to the crate to accelerate it at 2 meters per second squared? All right, how I set up each one of these friction problems, and I think is a good idea to always start by drawing a free body diagram. So here, this box is going to represent the crate. I always like to put the mass of the crate inside, so I don't forget. So the mass of this crate is 60 kilograms, 60 kgs. And then I go through and label all the forces that I can. We always know that gravity, force of gravity, is pointing down. So we've got the force of gravity, and that is equal to the mass of the object times g, which is the acceleration due to gravity. The mass is 60, and g is a negative 9.8. So let me get my calculator. 60 times a negative 9.8. I'm getting a negative, that's equal to a negative 588 newtons. Force always has newtons as a unit. Okay, and that's the force of gravity. We know it's being pulled along the ground, so it's not accelerating in the up and down direction. So the force that keeps it on the ground instead of falling through the ground is called the normal force. And that's going to be equal but opposite force of gravity. So the normal force is equal to 588 newtons. Okay. All right, so those two forces are labeled. Let's go in the left and right direction. It says that there was a force of 200 newtons that was pulling on this crate. And so this is our applied force, force applied, and that's equal to 200 newtons. Now if we're pushing the crate to the right, we know that there's a force opposing motion, and that's called the force of friction. But it doesn't tell us what the force of friction is in the problem. But this key term here, it says that it was being pushed along the ground at constant velocity. Whenever you see constant velocity, you should think the forces acting on the object are balanced. And if we have balanced forces here, you're pulling it at 200 newtons. That means to balance out the forces, you got to have the force of friction is also equal to 200 newtons. And so there we filled out our free body diagram. We labeled all the forces. We've got a label on all of them. And then we've also got a magnitude next to each label. So we'll refer back to this diagram a lot when we answer the questions, but I think that's a good first step in all of these problems, is to draw your free body diagram and label all the forces and put the magnitudes next to them. Okay, so now let's answer these questions. Number one says, what is the force of friction? Well, here's our force of friction, and we found it to be 200 newtons. So easy, that one's done. That is your answer to number one. Number two, it says, what is the coefficient of friction? For the coefficient of friction, we have to remember how to find friction, force of friction. Force of friction is really, we talked about this Greek letter mu. It's the coefficient of friction. That's what it means. And we take that coefficient of friction and we times it by the normal force. Okay, and then so we know two of these variables, but we don't know the coefficient of friction. That's what we're supposed to solve. So the force of friction, I'm just going to move this over and just plug in these numbers. So our force of friction, we found it to be 200 newtons. Okay, 200. And that is equal to our coefficient of friction, which we don't know, times the normal force. And we found the normal force over here was 588. Okay, so now we have an equation with one variable we have to solve for. To solve for mu, we would divide each side by 588 to get it by itself, newtons. Okay, so divide this side by 588 newtons. Anytime you divide something by itself, you can cancel it out because it's just equal to 1. And so mu is actually equal to 200 divided by 588. So let me put that in my calculator. 200 divided by 588. And I'm getting mu is equal to 0.34. And the coefficient of friction doesn't have units. It's just it's a unitless number, so 0.34 is your answer. Okay, so we've answered number 2. Now we just got to answer the last question. What force must you apply to the crate to accelerate it at 2 meters per second squared? So before, the forces were balanced and we were going at a constant velocity, but now we want to accelerate the crate at 2 meters per second squared. Whenever you see acceleration in these problems, think about Newton's second law, which says the force net is equal to ma. So down here on number 3, force net is equal to ma. Okay, we know the mass. The mass of the object was 60 kilograms, so 60 is what I'm going to put here. We know the acceleration because it told us, that's what happened. It told us in the problem that acceleration was 2 meters per second squared. And so I'm just going to put that 2 right there. And so my force net is equal to 120 newtons. And so force net is equal to 120 newtons. So what does that mean? That means there's not going to be a net force up and down because gravity and normal force are canceling each other out. But if you want to accelerate it left and right, you have to put a net force on it. Right now, the forces are balanced. So how do you find net force? Here's how I always think about it. The net force is equal to everything going to the right. So that would be your applied force. So force applied minus everything going to the left. And so everything going to the left is your force of friction. So our net force, we know it was 120. So if I slide everything over here, I'm just going to plug in the numbers to this equation. 120 is equal to your force applied minus the force of friction. The force of friction is not going to change because you're using the same object, and that's going to stay the same. Stay the same. Oops, that's a 0. Will be 200. So how do you solve for force applied? You add 200 to each side. 200 plus 120 is equal to 320 newtons. So let's think about what that says. You will have to, instead of applying a force of 200 newtons, in order to get it to accelerate, you have to apply a force of 320 newtons to get it to accelerate at 2 meters per second squared. So there's your answer 1, answer 2, and answer 3. Your assignment for this video is to solve this question. It says a force of 600 newtons is required to pull a 75 kilogram crate along the ground at constant velocity. So you're going to notice this question is exactly the same as the one I just solved. So if you get confused on it, refer back to the video and how we solved the previous one. Good luck. If you need help, stop by anytime.